Welcome back to another live CSEC graph class. Welcome. So this is the class where we focus on graphs, all kinds of graph, whether linear graph, quadratic graph, graphing inequalities, linear programming, solving quadratic equations, simultaneous equations, using graph, finding the roots of quadratic equations, all of that. We're still in the baby stages of the graphs class, and so we're still focusing on the linear graph, and this is the simplest of the graphs at this level. So tonight, what I want to do is we're going to plot 3 linear graphs, and we're going to see how to set up the tables, how to read the basic information given the equation or looking at the graph. So that's what we're about to get into right now. Hello, CSEC Maths. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. My new hat. Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have. Now, in this, we're going to be looking at common mistakes that students make with all the topics in CSEC. We're going to look at the common errors, demystify everything, make sure you watch everything in this series so that you can avoid those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? All right, so welcome back, and like I said, we're going to be plotting some graphs. So I'm not going to be sharing the screen tonight. I'm just going to be working from the board, and I think I might have to be shift my laptop as I go along. So I'm gonna take you so I have to shift as I go along. All right, so let me see which part of the board. So here. All right, so we need to see there first. Okay. All right, so we're focusing on the linear equation, and I'm actually going to be doing some very simple linear graphs first. Simple. For example, y equals 6, y equals -2, x equals 8, and so on. So let me just draw since these are going to be the really basic ones, I just need a little coordinate plane. Hoping you can see that. Alright. Just gonna do about 6 of these simple ones. Just to show you. And I'm going to quickly fill in my arrow and my x-axis. Just gonna quickly fill in the x-axis, y-axis, because we always have to remember to name our axes. Alright, so there we go. So we have 6 coordinate planes. When we get down to the bottom, I'll shift so you can see. Alright, so for this one, I'm going to write y equals 4, y equals -4, x equals 4, x equals -4. And let's do the common ones, y equal x and y equal -x. I'm always reminding you of those two because you should know them just like that. These are the simple linear graphs that you should know. So y equals 4. All you have to do is find where 4 is on the y-axis. So this is our origin here. Put in our origin 0, 0. So for the line y equals 4, whatever your scale is, whatever the scale is on your y-axis, just find where y is 4. So let's say 4 is here. It's going to be a straight line through. A straight line through the point 4. All right. I'm such a terrible host. I forgot to invite my guests up on the screen. I forgot to invite my guests. All right. So welcome, Imani.
Night, miss.
What a terrible host I am.
It's
Welcome,
fine.
Alex. Welcome, Roshan. All right, please forgive me for having you waiting in the hallway for so long. All right, so for the line y equals 4, and you're going to write the equation on the line y equals 4, right? So we just find where 4 is on the y-axis and draw a straight line, a horizontal line through that. For the line y equals -4, you find where -4 is on the y-axis and draw a straight line through that. That's the line y equals -4. How about x equals 4 and x equals -4? Likewise, for the line x equals 4, we find where 4 is on the x-axis. And it's a vertical line through that point. So, and you write your equation, x equals 4. So, to retract, where y equals 4, what will be the value of x? For the line y equals 4, what's the x coordinates at that point where y is 4?
Miss X would be 4.
X will
Wait,
be
no.
4.
Wait, no. Miss, what are we doing? I'm lost.
For the line y equal x, at the point where the line crosses the y-axis, what is the value of x?
1.
1.
Miss, which one are we doing, Miss? I'm lost.
I'm saying for this line where y equals 4 here, at the point where it crosses the y-axis, what's the value of x?
Miss 0.
0.
Okay.
Likewise for y equal -4. At this point here, x is 0. Remember,
Yes, ma'am.
along the y-axis, x is 0. Along the x-axis, y is 0. So for the line x equals 4, at this point here on the x-axis, y is 0. So this is the point 4, 0. This is the point 0, -4. This is the point 0, 4. So follow me now. For here now, x equals -4. So we go where -4 is on the x-axis, and it's a vertical line through that point. And this is the point -4, 0. At this point here, along the x-axis, y is 0, -4, 0. Now our common lines y equal x. So remember, for the line y equal x, it goes through the origin, straight through the origin, both negative and positive values. Whatever x is, y is. That's why it's y is equal to x. So if x is 1, y is 1. If x is -5, y is -5. So you should know this line. The line y equal x runs to the origin, is oriented to the right. The line y equal -x is the opposite of that. It's oriented to the left, still going through the origin, but whatever x is, y is the inverse of that. Or y is the negative of that. So if x is 1, y is -1. X is -3, y is +3. The opposites, they're opposites to each other. So these are some of the basic lines. So now we're going to plot some lines using, so we're given the function or the equation. These are linear, so straight lines you're going to get. And I'm going to show you how to draw your table and get your coordinates to plot the lines. So I'm going to do one where the x is negative and where it is positive. So for example, y equals 2x plus 6. That's our function, that's our equation. And this, what do we call this here? What do we call it and what does it tell us?
Miss, it tells us it's called the domain, and it tells us where we want the range, what the range of the graph will be. So it's between -3 and 4.
No, the domain is the domain is your group of x values, and when you plug them into the function, you are going to get your range, which is your group of corresponding y values, right? So the domain substituted into the function will give you your range.
Okay.
Now, so this is your equation.
So Miss Mrs. passes 6 on the y value. Missy passes 6.
All
Missy
right. So
passes
John
6.
is saying, how do you know, John?
Miss, Miss, I watched your video on the quadratic graph, Miss.
Mm-hmm.
Miss, and you said the value after the plus, Miss. It tells you where the graph is supposed to pass.
So what do we call this term out here?
Miss, that's just constant term. Oh.
The constant term, or is also called the y-intercept. So what John is saying is that this number out here tells you where the line will intercept or cut across the y-axis. So we know from now, even before we rule up our table, even before we plot our graph, we already know where the line should cut the y-axis. What else can we tell from the line based on the equation? What other information? This number here in front of the x tells us what?
It's the gradient, miss.
What we're supposed to
Gradient. So it tells us the gradient of the line. Okay, so the gradient is 2. The y-intercept is 6. So let's use our domain values, plug them into the equation and get our range values. Because it's a line, we only need the end values of the domain, and we usually put 0 as well to see what's happening at the origin. So we just need the ends. If it was a quadratic function, we would try to get all the points from one end of the domain to the next, all the points in between. Since we're going to be getting a curve, we want to make sure we have that smooth curve, so we put as many of the points as we can get. For the line, we only need 2 points to connect. So first, we're to multiply the x values by 2, and then we're to add 6 to get our y values. So multiplying -3 by 2, we get -6. Multiplying 0 by 2, we get 0, and 4 2 is 8. And now we're to add 6. So -6 plus 6, this gives 0. 0 plus 6 is 6, and 8 plus 6 is 14. So our coordinate pairs that we're going to be plotting, -3 to 0, 0 to 6, and 4 to 14. So remember, the first value tells you where to move on the x, and the second value tells you where to move on the y. So using our coordinate pairs, we're going to plot. Okay, Drayshawn is waiting. Those who are on the screen, I wouldn't mind if you would turn us on. Welcome, Drayshawn.
Good night, miss.
All right, so these are our coordinates that we're going to plot. So we're going to decide our scale that we will use on both axes. On the x-axis, numbers tend to be smaller. The biggest digit we have here is 4. We can space out the values on the x. So we can actually go by 2 spaces to 1 unit on the x-axis. The y-axis, the numbers tend to be bigger. So I'm going to space out my x-axis. I'm going up by 1. So this is the negative x, positive x, negative x values. So remember, we number from 0 out. From 0 out. On the y-axis, in this case, our biggest digit is 14. So I'm going to go by 5 on the y, so everything can hold. So 1 centimeter to 5 units. And you have to be consistent. So on the negative y, same, 1 centimeter to 5 units. All right, so let's plot now. So -3 to 0. So -3 on the x and 0 on the y. So that's right there. We don't move on the y, so we stay on the x-axis. 0 to 6. You can't see. So those are the values we got, right? 0 to 6. So 0 on the x and up from there to 6 on the y. And 4 to 14. So 4 on the x up to 14 on the y. And then we're going to connect our points and write the equation on that line. All right. So if you were unable to see when I was working out the table, there it is. So I put my x coordinates from -3 to 4. That's what the domain told me to do. And then I went to my equation and I multiplied each x value by 2. So that's in this row. Each of these times 2. And then I was told to add 6, which I did. I added 6 to each of them. And those were the values that I got. So plotting these values on the graph, no. That's the line that I got. So we're going to work on another line now. This time, I want the x coefficient to be negative. So let's do -2x plus 6. The difference here being this was a positive 2x. This is a negative 2x. So we're using the same domain, -3 to +4. And we're going to see the difference it makes just by the coefficient of the x being this time. So let me shift so you can see. So that's what we're working out this time. So we have -2x plus 6. So we have -3, 0, and 4. -2x plus 6. So this will give us -2 times -3 would give a +6. -2 times 0 is 0. -2 times 4 is -8. And we're going to add 6. So now we will have 12, 6, and -2. So the coordinate pairs will be -3 to 12, 0 to 6, and 4, -2. So let's plot those and see what difference it makes in terms of the orientation of the graph. By the way, what's the gradient of this graph?
Mr. Scream, Mr. Someone froze up, miss.
Pardon me?
Mr. Freeze up, but it's okay now, miss.
All right, so I'm asking what's the gradient of this graph, this line here?
2x, miss?
-2x. -2x.
Miss, you asked for the gradient.
So why are you saying x with it? X is not part of the gradient. The gradient is the coefficient of x. The gradient doesn't x.
Miss, it would be -2 then.
So the gradient is -2. So for the first line, the gradient was 2. For this line, the gradient is -2. What is the y-intercept for this new line? The equation was the same except for the 2 and the negative 2. So what's the y-intercept? Did you hear the question?
No, miss.
What is the y-intercept for this line?
Miss positive 6.
Positive 6.
Yes, miss.
All right, so for both of them, the line should cross the y-axis at positive 6, right? Okay, so let's plot the line and see. So negative 3 to 12. So negative 3 up to 12. 0 to 6. So 0 to 6 again. That's constant. And 4 to negative 2. 4 on the x, negative 2 on the y. And then we connect the points negative 2x 6. All right, so what do you notice about the graphs?
Miss is orientated a different way.
Opposite. Yes,
Yes,
miss.
it's opposite. It's in the opposite direction.
Right, so this one is oriented to the right, and this one is oriented to the left. So when the gradient is positive, the line is oriented this way. When the gradient is negative, the line is oriented that way.
Yes, miss.
Okay, so that's another thing you can tell from the equation. Just looking at the equation, not only can you tell the y-intercept or where it will cross the y-axis. In both cases, the intercept is 6. It crosses the y-axis, that's positive 6. So that can tell, but it also can tell you what the gradient is, as well as how the line will be oriented. Will it slant towards the right or will it slant towards the left? All right, so we're going to do one more linear graph, and this time it's just going to be a little tip more complicated. We're going to have to do some maneuvering first. But let me set up my coordinate plane. All right, so let me set up my coordinate plane. But suppose you're given something that looks like this. And you are asked to plot that graph, and this is your domain. How would you approach? Suppose you were told, this is a graph, I want to plot the graph, and that's the domain you must use. Tell me your approach to that.
Miss, so I think we're going to try to get y on one side and the rest of the equation on the other.
Oh, yes.
So first we're going. Okay.
You're going to try to get y on one side,
Yes, miss.
the other equation, the other variables,
On
the
the
other
other side.
variables on the other side. How do we do that, and why are we doing that? Why do we need to do that?
Miss, to get the point, to get how do you say that? To know the range in which we're going to plot the graph. Or no, not the range. To get the points to plot the graph.
Why do we need to get only the one on one side and everything else on the other side?
It's because Miss because a normal equation would be y equals x, y equals a normal graph equation would be y equals.
So remember,
To
our
know what we're going
general
to.
format of the linear equals mxc, where m is the gradient, c intercept or the constant term. We must get our equation in that form first before we set up our table and start to plot. So this is not yet simplified in this form. So this says we must have the y on its own, preferably to the left. We must have our x variable with the coefficient and the constant term, just like this. So let us simplify this until it is in this form. So Imani, what do you say we do?
Miss, we're trying to get y on one side of the equal sign and the rest on the other.
So what's the first thing we do here?
Means we're going to put y on the other side, negative y on the other side, which would make it a positive y, and carry over 14, which would make it a negative 14.
Alright, so we're gonna bring over the negative y or add y to both sides then, right?
Yes, miss.
And while we're doing that, subtract 14 from sides. So we
Yes,
would
miss.
have negative 3x plus 2x plus 6 minus 14 equals y. So we
Yes,
added y to both sides to get rid of the y over here. And we subtracted 14 from both sides to get rid of the 14 on the right. So what next?
Miss, now we're going to solve the distributive law or the brackets.
So we're going to use the distributive law to expand the brackets. So we write back our minus 3x. So what's 2 times x?
Miss, that's 2x.
2x.
And 2 times 6?
Miss is 12.
12.
Positive.
So simplifying now, we group our like terms.
Yes, miss.
So negative 3x plus 2x.
Miss, that would give you negative x.
And 12 minus 14.
Miss, negative 2.
Negative 2.
So now we simply have to kind of shift around because we want the y on the left, preferably, right?
Yes, miss.
Y is negative x minus 2. So this equation, which looks so complex, we have simplified it to this. All we did was expand the brackets and group the like term. Right? Under the brackets, and we grouped the like terms. So now we're working with. This is what we're working with. So we have our domain, and now this is in the form of y equals mx plus c. What would be m in this case? What would be the gradient? Anyone? What's the gradient of this line?
So
Miss,
the
I can't see
spring,
the equation.
With me, I can.
the spring is
It's the
frozen.
grade.
Oh, sorry about that. The gradient would be what? This line.
Miss, -1.
So -1 would be the gradient.
Yes, miss.
And what would the y-intercept?
Miss, -2.
So the line would cross the y-axis at -2. The gradient is -1. The 1 isn't there, but we know it's there. We don't see it, but we know it's there, right? Negative x is really -1x. Would the line be oriented to the left or the right? It has a negative gradient. Would it be oriented to the left or
It's
right?
to the right. It's to the right. To the right.
Right.
You sure?
Yes.
Yes, miss.
You sure?
Yes, miss.
So when the gradient was negative here, it was oriented to the left.
Is that the left?
To the left.
Yeah.
So
So this one will be oriented to the left as well.
yes.
So let's have our. I'm going to do the table for this here, just so you can see it while I'm doing it. All right. So it's y equal -x minus 2. So our x values would be from -3 to 4, and it's -x minus 2. So if these are our x values and start with them being negative, we just change the sign. So this would be 3 and that would be -4. That's -x. And now we're subtracting 2. So 3 minus 2 gives 3 minus 2.
Miss negative. Wait, miss 1. Miss that's 1. Miss
Miss
that's 1.
-1.
Miss that's 1.
3 minus 2 is +1.
Yes.
0
Miss
minus 2
Miss -2.
and -4 minus 2.
-6.
So our coordinate pairs will be -3 to 1, 0 to -2, and 4 to -6. All right, so that's what I'm going to plot now. So my y values, I can actually go by 2 on my y. The numbers are not very big at all. On my x, 2 units, 2 spaces to 1 unit. Sometimes you're doing your graph, you can get some really big numbers. So be prepared to adjust your scale accordingly. Right now we're dealing with some baby numbers. So it's -3 on the x to 1 on the y, -3 to 1, 0 to -2. So that's 0 and then down, -2 on the y, and 4 to -6. So +4 on the x and down from there to -6. So as we guess, the line is oriented to the left. The gradient -1 says So just like that. And we're going to write our line y equals negative x minus 2. Y equals negative x minus 2. So oriented to the left, we knew that because the gradient is negative. It's negative 1 to be exact. And the line cuts the y-axis at negative 2. And we knew that because the equation is y equals negative x minus 2. All right, so let's go over the points that we made. All right. So we started off by plotting very simple lines. The lines like y equals 4, y equals negative 4, x equal 4, x equal negative 4. And line y equals 4 is just a straight horizontal line that runs through the point 0, 4. So it cuts the y-axis at 4. It's horizontal, meaning that it is parallel to the x-axis. So the line y equals 4 is parallel to the x-axis. Y equals 6 is parallel to the x-axis. Y equals negative 2. All those lines are parallel to the x-axis because x is 0 in all those lines. The line y equals negative 4, likewise, it's a horizontal line parallel to the x-axis, and it cuts the y-axis at negative 4. The line x equals 4 is a vertical line. So straight down, it cuts the x-axis at the point 4, 0. So it cuts through the x-axis. That means y is 0. Anywhere along the x-axis, once it's a vertical line cutting, y is 0 on the x-axis. Same thing for the line x equals negative 4. It cuts the x-axis at negative 4. It's a vertical line running straight through negative 4 on the x-axis. All right, so knowing that, we also went on to plot the lines x equal y, or y equal x, and y equals negative x. And I've been stressing that these are lines you should know by heart. You should know these lines anywhere you see them. So all it simply means for the line y equal x is that whatever the x value is, the y value is the same. So x is 0, y is 0, x is 1, y is 1, x is negative 10, y is negative 10. So with that pattern, what you find is that the line will cut through the origin at 45 degrees, at a 45-degree angle. So it cuts through the first quadrant and the third quadrant. And of course, it continues to infinity. All these lines that we've mentioned so far, they are infinite. They go on and on and on. The domain just tells us where we should focus on, which x values we should stop at. But these lines, you could continue them indefinitely. And the line y equals negative x is opposite to the line y equals x. It is oriented to the left. And whatever y is, x is the negative of that. Or whatever x is, y is the negative of that. So except for 0, which it's still 0, 0, it cuts to the origin and at 45-degree angles. This time, the line y equal negative x will cut through quadrant 4. So the coordinate plane has 4 quadrants. The first 90-degree measuring from the x-axis up, so that's the first quadrant, and the second quadrant, and so on. Just like how you would cut up a circle into quarters. All right, think of it that way. All right, so then we went on now to plotting more complex lines, still straight lines though. And we said that the general format of a straight line is y equals mx plus c, and you are able to know certain information just by looking at the equation. So just by seeing the equation, we can know at least 3 things. What are those 3 things that we can know? Go ahead, Dreshan. Did you have your hand up, Dreshan? I'm asking, what are the 3 things that we can know simply by looking at the linear equation? What can we know about that line?
Miss, the where it's supposed to pass through.
And how it's going to be oriented.
So where it's supposed to pass through, that's not complete.
It's like
Okay, how do you say that?
constant. I would.
Where,
What was the term that I used for that? So
the
the
intersect.
constant, first of all, we need to make sure it's in the format of y equal mx plus c. It must be in that format first.
Yes.
With the y on the left and everything else to the right, with the x coefficient and the constant term at the end. Okay? When it's in that format, what does the constant term tell us about the line?
Miss.
Miss, it tells us. Okay, so Miss, it tells us well we already know what it tells us, so we're trying to figure out what.
It tells us where the line is going to be.
Okay, Miss.
Like in terms of on the. I
It
don't know
tells
how to
us where
explain.
the line. It tells us where the line will cross the y-axis.
Oh yeah.
Yes.
Miss.
Basically.
And what's the term that we give for that? There's a term that I used.
Miss, the
The
equation.
y-intercept.
Intercept.
Say that for me, the y-intercept.
Intercept.
I
Okay.
intersect.
The constant end is the y-intercept. It tells us where the line will cross the y-axis. What else can we tell about the line just looking at the equation?
Miss, where it will like John said, where it's how it's orientated. Oriented.
Okay. So what does it tell us about how it's oriented?
Miss, if it's negative, it would be oriented. It would be oriented. The left, Miss, and if
If
it's
it's negative, if the x coefficient, if the number in front of x or the x coefficient is negative, then the line is oriented in what way?
left, Miss, the left.
To the left. And if the x coefficient is positive,
It's going to the right.
the line is oriented to the right. What else can we know about the line other than y-intercept and orientation?
We would know. We can.
Alex, do you remember? What else can we tell about the line? The coefficient of the x term, what does that tell us?
If like if it's X.
Miss where the line is
Yes, it tells us
will
what they're
be.
going to.
The coefficient of the x, the number in front of x, tells us what about the line?
Where let's see.
It tells us the gradient of the line.
Oh, I'm just forgot about the gradient. I was
Yes,
going to
it
say
tells us the
I was
gradient
like
of the line.
that's already in the equation. So
So you're overlooking the obvious then. So
yes.
it's too obvious for you to see it. Is that what you're saying?
No, miss. No.
It's too big for you to see. So
Miss, it's
remember
so
the general format of the linear equation, y equals mx plus c. M is the x coefficient. M is the number in front of x. M tells you the gradient of the line.
yes.
C, the constant term, is the y-intercept. Remember, there is a formula for working out the gradient of the line. If you are given at least 2 points along that line, Imani, we did that today, remember? Or was it
Yes,
yesterday?
you guys did that today? Yes, because yesterday was Sunday. Oh yeah.
Today. Now, I know it's recent. I'm trying to remember exactly which. But the gradient, right? Gradient is there's a formula for working out the gradients of the line. If we're given 2 points along the line, in this case now, you can know the gradient simply if you are given the equation of the line. Just look at the number that's in front of the x term. So x is the variable and the number in front of it, the coefficient. The coefficient of the x term is the gradient, plain and straight. Any number you see there, that's the gradient of the line. So if you were to take any two of the points that we got, let me see, what were the points? So let's say we took one, we had what? One, like -3, 1, and 0, -2, right? So -3, 1, 0, -2. And it would be, so the formula would be y2 minus y1 over x2 minus x1. So in this case, it would be -2 minus 1 over -3 minus 0. And we would have -3 over -3, which would be what? -3 over -3, that would give us 1.
One.
Yes, miss.
Okay. Actually, 0 minus -3 would give -3. So it would be would give a +3. So it's -3 over +3. So it would be a -1. And see, just looking at the equation, you would see the gradient is -1. So you can take any 2 points, use the formula y2 minus y1 over x2 minus x1. That will give you the gradient. If it's the points you're given, if it's the equation you're given, just look for the number in front of x and you already know the gradient. All right, so that's the wrap for tonight for our graphs class. Remember, tomorrow is algebra.
Beautiful, beautiful.
Not really beautiful.
Beautiful.
It's the hardest. Please
Algebra.
remember, we're just solving math problems. We're changing lives.
We're not just solving math problems, we're changing lives.
Yes,
Thank
Miss.
you, sir, as always.
Yes.
Have a wonderful night, scholars.
You too, Miss.
And please revise what we have done so that you will keep that fresh in your minds and keep adding to that as you go along.
Yes, Miss.
See you
Yes, miss.
tomorrow.
See you
See
tomorrow,
you
Miss.
tomorrow.
Bye.
Good day, all. Bye, bro.
Bye.
It's beginning to look a lot like Christmas.
Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because you're making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one error or one mistake? Well, this is absolutely true. And we're going to be looking at the common errors that students make in the different topics of mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.